Hey, what's up? This is Corey Glenn. I wanted to show a unique case that I've been working on with Dr. Jerome Smith, who's an excellent implant dentist down in Louisiana. He had a case that we've been exploring doing a custom grafting mesh. So this patient, as you look at their maxilla, it's very, very atrophic. Not a lot of great options on these kind of patients. You can do big block grafts, but they're very difficult. And so one of the things that has been shown previously is just the use of a custom cage mesh type thing that can be used to contain bone grafting materials that can be rigidly fixated to the patient. And so we wanted to explore whether or not we could do that without having to use some really high-end software and medical imaging companies and all that kind of stuff. So I'll show you the process of how this was done, and I think it's really going to work out nicely. The first thing he did was he took a cone beam of that patient, and I went through the process of doing bone segmentation. So if you go up to panels and segmentation, you can go here to advanced jaw segmentation and go through that process. That will take you a little bit of time, so I'm not going to show that in the video. I've got other YouTube videos demonstrating that. But the end result was that I ended up with this STL model of that patient's jaw that's very accurate. You can see how well it conforms to the bone up here in the slices. And so with this, what I did was I went ahead and got this thing ready for printing and gave it to Jerome, who was going to then wax the jaw up to ideal. Now that could have been done digitally, but sometimes it's worthwhile just to print something out and do a physical model. It was quicker, it was easier, and didn't require as much software know-how. And so what I did is I just went up and export data. Let's export just this green model, and we'll call this jaw to print, and we'll save that to the desktop. And now I'm just going to go and open that on a program called Mesh Mixer, and let's open that up in Mesh Mixer. Now the end goal here is that I want Jerome to be able to wax this up to ideal and then give it back to me, and I'm going to rescan this in its new form and then stitch that back into the original case. Now you could go about stitching that with conventional means, which is click a point here, click a point there. But to make that process easier, I went in, and you can see they're already present on this one, but I put these little dots. Now these are not in the patient's real anatomy. I've just put those in non-critical areas to give me stitching points. And if you wanted to do that, just go up here to Mesh Mix. You can drag one of these little dots and size that to whatever you want. You can create a new object or just append it to the mesh, meaning add that to the mesh here. And so we did that, and that's going to give us something on the physically printed model that once I rescan it will make it easy to stitch in. So at that point, what Jerome did is he went ahead and printed out that jaw, and as you can see, just used some base plate wax and waxed this jaw up to an ideal ridge form, and then just did a little drawing on the computer of what he generally wanted that mesh to look like and where he wanted some fixation pins. So this is what we're going for. And what he did was send me back this physical model that had been printed and waxed up, and I rescanned that. I used a desktop scanner, the Shining 3D scanner, and that gave me a new STL of this patient's jaw. So now back to Blue Sky Plan. If I was to pull in that waxed up jaw, you can see here that it's been stitched in nicely. The contours are exactly matching up, but the interesting thing is now that you can see everything lines perfectly up except for the areas where that bone deficiency was. So especially as we come up here towards the anterior, you can really see how much volume is going to be added by creating this cage or this mesh. Especially in the anterior region, you can see this is a lot of bone that needs to be grafted on. And really, one of the biggest problems in trying to do large grafting cases is keeping that graft immobile and very stable. And that's what the cage is going to accomplish, is once it's fixated in there, there's not going to be any pressure that gets to be applied to that graft. So we've got this now, and now we just need to do the process of creating the mesh. Okay, so once again, you've stitched this in, it's in the right position. Now you can go up to File, Export Data, and export this model of the now waxed up, ideally shaped jaw. Okay, so let's now import the waxed up jaw and this is going to be waxed up jaw. All right, once again, you see it meshed over the original model, and let's just turn the original model off now. And we need to define what is the boundary of this going to be. Now, there's a number of ways that you can do this. I'm just going to show you the way that I did this particular one. What I'm going to do is go up to the Select menu, and I'm going to use this Select Spot tool, and I'm just going to begin defining where this mesh is going to be. So I'm going a little bit beyond where he wants to, where he's got waxed up, so that we can have this resting on some nice native bone that's already there, and that will provide some stability to this. So I'm going to come down and around. I'm going pretty deep here. This thing will be easy to trim back should you want to, because it's only going to be about 1 millimeter thick of titanium. But if you don't have enough, that's hard to deal with. So we're going to go pretty generous on our boundaries, and then I'll leave it up to Jerome where he wants to trim this to. And back to the start. And now we need to begin defining the rest of the cage. So that's the boundary. I want to have one piece of metal that's going to be sitting right on the very top of the ridge. So I'm just continuing this on, right on the top of the ridge, and then I can begin looking from the sides here, and I'm going to add another layer. And now we can start going up and over. Same thing on the lingual side. And now you see the general outline of how I want this to be. Make sure it is continuous everywhere. I can see right there I didn't quite get it all touching. So make sure this is all one continuous piece. And now I want to smooth this boundary. So let's go up to Modify, and let's first optimize the boundary, and then back to Modify and Smooth Boundary. And as you'll see, this blue outline indicates the new boundaries that are going to be much cleaner and not so jagged on their edges. So we have this object now, and what I want to do, while it is still selected, you can see if I was to turn that off, now it's going to be its own face group, but it's all still part of this same STL. What I'm instead going to do is select all of that, and I want to offset that by just a little bit. So if you think of like a guided surgical guide, usually those have a little bit of an offset spacer between the model they're built on and the internal of that guide, so that there's a little slop space for that to sit properly. Usually something in the order of about 20 microns. So I'm going to go ahead and put in 0.2 offset and accept this, and now you'll see, if I was to really zoom in closely, what offsetting does is creates a second layer. So we had that original green layer underneath, but in all dimensions it has offset this to where there's now a separate layer, but it's still part of the same STL. Now I want to now make this its own STL. So let's go up to Edit, whatever you have selected orange. Again, if I was to lose this, let's click on just that outer shell, and then go up to Edit and Separate. Now it is its own independent STL, which is offset by a little bit. Okay? Once that's done, now we need to create some three-dimensional thickness to this, because as you can see, this is just an exterior shell right now. This is not even a physical object that could be printed. So the way I'll do that is by going up to the Select menu. I'm going to, again, double-click this, select it all. I'm going to smooth it real quick as well. So if you hit the Smooth button, you can say max smoothness. It really depends on what you're going for, but let's accept that. Now I'm going to go to Edit and Extrude. Now you're going to need to change your extrusion direction to normal. Okay, so now you can see that that is expanding it out in all directions. And as far as thickness, we have to have a minimum thickness of 1 millimeter to be able to 3D print this, at least with the company I've dealt with. And so to make sure that we've got that, because I know in later steps this might get rounded off a little bit, I'm going to create an offset distance of 1.2 millimeters. And now you can see that we've got this completed. So accept that. And inevitably, you're going to have some little spikes and things off of this. What those are is little folds in the mesh. If I was to take a brush, like the smooth tool, and just click on that, you would see those begin to disappear. But I don't want to sit here and go around all of these little things and try to fix that. So rather, what I'll do is take this object that I've got now, and I'm going to go to Edit and Make Solid. Now the Make Solid is going to condense the mesh a little bit, simplify it somewhat, but still maintain its overall dimensions and shape. And as you can see, this looks like it's pretty good. So I'll accept that. And now we've got this cage that can go onto the maxilla. It's got lots of room for the blood supply to get in there, to make sure that there's adequate blood to the graft. And the only thing that's left to do now is to create the screw holes for Jerome to be able to screw this onto the maxilla. So I'll show you how to do that in just a moment. I do see just a couple more little spikes that I want to take care of. There we go. Okay, so now how am I going to create these screw holes for this? Well, if we go back to Blue Sky Plan, I need to make sure that my screw is not going to be sticking up into the sinus or something like that. And so what I did is I went up and I created some custom implants. So if you were to go up here to add an implant, and let's do a custom implant with a length of, 10 millimeters would be fine, apical diameter. So on our diameter, we need to know the size of the screws that are going to be used. He let me know that the lag screws he's going to be using to secure this are 1.8 millimeters in diameter. So I'm going to make this a perfect cylinder with an apical and occlusal diameter of 1.9, so a tiny bit bigger than his screw. And now I'm going to OK this and drop this into the case. So I'm going to drop one right up here in the front of the mouth, and we can begin positioning that. If I hover over this now, I can look at where that is going to go. And really what I'm aiming for is to make this go through the buckle of the mesh and make sure that it's going into the bone here. Okay, now he'll choose the depth in surgery to make sure that it's not protruding all the way through. We could make it go all the way through if you wanted to, but really my main goal is just to have the fixation done from one side. So we've got one right here. We could now duplicate that implant. So right click it, duplicate, and then drag another one over. And let's suppose that you wanted to put another one from maybe the canine side on each direction. So we'll drag this over. And this is where we want to probably go as far back as we can without getting into the sinus. So this is the best view to observe that in. You can begin seeing the sinus here. And so let's go about right in that direction. And as I go up and down through this, I can see that is not going to violate the sinus. So pretty happy with that one. Let's look at it in the three-dimensional view. Okay, that looks great. And now let's do one more. Right click, duplicate, and drag that over to this side. And once again, let's maximize this window. And here you can see that implant. And it looks like where I drug that is going to work perfectly. Maybe change the trajectory slightly. And that looks good. Okay, so here's my three, what's going to become my three screw holes. They're 1.9 in diameter to accommodate his 1.8 millimeter screws. And now what I'm going to do is export these implants. So export data. I want to uncheck all these models. All I want to export is these implants. We'll call this custom implants and save it to the desktop. And now back to our mesh, we can import and append the custom implants. Okay, so here you see where these are positioned. And right now they're all saved as a single STL. I'm going to separate them out now because I want to independently move them a little bit. So I'll double click that with the select tool and say separate. Now it's its own object. Now I can come and select, double click this one, make sure it's all selected, and then separate. So now you can see I've got three independent implants. 1, 2, 3. And I need to manually move this one up just a bit. Okay, so if you look at it from this direction, it needs to come. I'm going a little anterior, so I'm not worried about it, getting in the sinus or anything like that. I'm just going to make sure that it's right in the bulk of the material. Right there, that looks great. That should be easy to accommodate. This one I can go up just slightly with. So once again, T for transform. Go up just a bit, accept it, and one more here, T for transform, and let's go up with it as well. And if it looks like that's going to be a little thin, maybe it would be worthwhile to bring this up here to a thicker area, where that can accommodate it more. Again, I'm not going more posterior, so I'm not worried about the sinus. And you can add as many of these as you want, but this looks like that's going to work pretty good. Now I need to subtract those. So if I select the initial cage, okay, that's what I've got selected here, and then push Control and select, you can see that now it's Control selected this, and a menu pops up that says all this stuff. I want to do a Boolean difference, and I want to uncheck where it says Auto Reduce Result, because otherwise it will collapse that. But as you can see, what's happened is that the software has subtracted out that 1.9 millimeters diameter cylinder, creating now a hole to accommodate that screw. Let's just repeat it with the other two. Boolean difference, auto reduce result, accept, and one more, Boolean difference, auto reduce, and accept. Okay? This is our final mesh. This can now be 3D printed by any lab that is capable of doing titanium 3D printing, because this is going to be implanted. They have to make sure that they've got the right FDA clearances and everything, but there are medical printing companies out there that can do this. The one that I've dealt with has to have a minimum thickness of 1 millimeter, and so you can go to the analysis and run a thickness inspection on it, and you can see what the thickness of this is. And so you can see if I tell it a minimum thickness of 1 millimeter, it brings my attention to any spot where there might be a little bit thinner than that. And some of those I'm seeing are in the areas, again, like right here. These are kind of non-critical areas, so I don't think this is going to be an issue, but you'll have to submit it. If they say that they can't print this, you might just go back and repeat the process, but this time bump up, instead of 1.2 thickness, bump it up to 1.3, 1.4, something like that, so that you maintain that minimum thickness. But this is really the end of it. You'll print this now in titanium, get it all sterilized and everything, blasted really nice and clean and ready to implant, and then day of surgery, this will fit very nicely into the mouth, and you'll be able to deliver this and do the bone grafting.